Welcome to the Project Management Prepcast, helping you prepare for the PMP exam. Here's your instructor, Cornelius Fichtner.
Hello and welcome back. This is part 2 of our lesson on the Plan Quality Management process. I'm your instructor, Cornelius Fichtner. Did you miss me? In part 1, we covered the overview and the inputs for the process. And now here in part 2, we're going to focus on the tools, techniques and outputs and review and of course a couple of sample exam questions as well. Let's continue. You may remember from our somewhat more in-depth review of the ITTO overview from the PMBOK guide that we have 8 tools and techniques for this particular process. And the first 6 are the cost-benefit analysis, cost of quality, the 7 basic quality tools, then there is benchmarking, we have design of experiments and statistical sampling. Next, we have additional quality planning tools, and here we're talking about things like brainstorming, force field analysis, the nominal group technique, quality management and control tools, and lastly, meetings. Yes, we're going to have to sit down with other people and eat a few donuts. Let's look at the details of the tools and techniques. Quality can be quite expensive to achieve. However, there's a golden rule in quality that all benefits must outweigh the cost. Crosby said that quality is free because the actual cost of implementing a quality system will outweigh the cost of non-conformance. The question is, of course, is this true? I certainly wouldn't implement every single last bit of a quality system just because Crosby said, well, it's free. I would have to know the cost versus the benefit. Then I would be able to choose only those areas that truly render the most, shall we call it, bang for the buck. There are trade-offs between cost and the gain of quality-related activities on the project. A cost-benefit analysis for each quality activity examines the cost of the quality step to the expected benefit, and no activities should be performed that cost more or even equal the expected benefit. Of course, only those things that bring true benefit will end up in the quality management plan. In terms of the cost-benefit analysis, and also to explain why Crosby said quality is free, if we are willing to invest into a quality program in our company, then the savings will be much greater than the actual cost of the program. This is because we no longer have to fix those products that were produced at an unacceptable level of quality. That makes a great deal of sense, doesn't it? But there is, of course, an expense associated with quality. And this, what we know as cost of quality, is the technique of evaluating all the costs that will be realized in order to achieve quality. It is actually defined as a method of determining the costs incurred to ensure the quality. It includes all of the costs gained over the life of the product. So any cost that you invest to prevent poor quality or spend as a result of poor quality is part of the cost of quality. This includes expenditures for rework, recalls, high maintenance, or cost of failure. Yes, it costs to fail, so those costs are included as well. Generally, you can divide these costs into 2 distinct categories. They are the cost of conformance and, of course, the cost of non-conformance. Or to boil this down into one sentence, cost of quality pertains to the total cost of the conformance work and the non-conformance work that should be performed in an effort to achieve quality. Let's go more into details on each of these 2 categories. The cost of conformance, our first category here, is the cost of completing the project work to satisfy the project scope at the expected level of quality. It is the money that is spent during the project to prevent failures from occurring in the first place. So If we invest into the cost of conformance, we invest into ensuring success from a quality perspective. We include all the cost that you must expend in order to make sure that your quality standards are met. And within cost of conformance, we know two categories. The first one is prevention cost. These are the costs that are associated with building a quality product or service, so that any errors that do occur are within what is considered an acceptable range. These usually include the elements of training and equipment. Also included in this category is the time and effort required to fully document processes and to do things the right way. The second subcategory here is appraisal costs. These are the costs associated with determining the level of quality to ensure that it meets our required standards. Included in appraisal costs are things like inspections and various types of testing, the results of which are then evaluated to ensure that the quality expectations are being met. Let's take a look at those two subcategories side by side to get a better overview here. So we have on the one side prevention cost as a subcategory within the cost of conformance category. Again, those are the costs associated with building a product. This could be training, equipment, process documents, restructuring, manufacturing lines, anything that you do to make sure that the output is according to what the quality says it should be. Second, we have the appraisal cost as a subcategory. Again, those are the costs associated with assessing the quality of your product. And here some examples are field testing, inspections, quality audits, and defining and documenting your quality systems. And then we have the cost of non-conformance. This is, of course, the cost that is occurred when you complete project work that is not following your quality requirements. If there is a choice made to not conduct quality activities, then there is the potential for cost associated with any resulting problems. Those costs, those are the cost of non-conformance. It is the money that you spend during and after the project as a result of, well, failures. If we pay for the cost of non-conformance, that means we are paying for work that was not properly planned and performed, and work that was created below quality standards. These costs can include such things as payments made out on warranties, rework, scrap, or damage to our reputation. The biggest cost here are your expenditures for having to perform rework. This all goes back to the phrase that was coined by Crosby. You know, that acronym, DRFT, do it right the first time. Cost of non-conformance can include things such as payments made out on warranties, rework, or scrap, or damage to the reputation. It's easy to see that there is a potential correlation between the amount of money spent on conformance versus the cost implication of non-conformance. Cost of non-conformance is sometimes also called failure cost. And just like we had two subcategories in the cost for conformance, we have two subcategories here under failure cost, or the cost of non-conformance. We have the internal failure costs. These are failures found by the project and the project team. And some examples here are rework of products or components, production waste, or fixing processes that just aren't working out. And then, of course, if we have the internal failure cost, we have the external failure cost as well. This is when your customer identifies a failure on your project, and this is where you really don't want to go. Some examples here are product repairs during the warranty, lawsuits, and, mentioned this a couple of times already, loss of reputation, and even worse, loss of customers. If you produce a low-quality product, then there is a price to pay. You may experience low sales or a great deal of downtime on your system as it requires maintenance and repair. In worst-case scenarios, it may even be necessary to recall the product, and this is where we get into costs that are very difficult to measure: the loss of customer confidence and loyalty. Crosby fully believed that the cost of conformance greatly outweighs the cost of non-conformance. By doing it right the first time, you will deliver quality work, and the project team does not have to perform additional tasks to deal with rework. If we are willing to invest into a quality program in our company, then the savings will be much greater than the actual cost of the program. This is because we no longer have to fix those products that are produced at an unacceptable quality, and that is why Crosby said quality is free. Our next tool and technique, the 7 basic quality tools, is also referred to as the 7 QC tools. They're all used within the framework of the Plan, Do, Check, Act cycle, the PDCA cycle, to resolve quality-related problems. If you recall, Plan, Do, Check, Act was defined and detailed in the overview presentation here for project quality management. But in short, it's an iterative 4-step control strategy to ensure conformance to quality requirements. These quality tools are quite generic, so they can be applied to any condition in an organization. The merit of these tools is that they can provide a great deal of information about problems in the organization and assist in deriving solutions for those problems. The 7 basic quality tools is a description given to a fixed set of graphical techniques that are recognized as being helpful in troubleshooting quality-related issues. Being termed as basic does not minimize their usefulness. Instead, it means that they are suitable for people with little formal statistical training to implement, and that they can be used to solve the vast majority of quality-related issues. It must be noted that quite a few of these tools, they come with a hefty price tag to implement. With that being said, it might be a good idea to provide training for someone to effectively use these tools. Here's an overview of these 7 basic quality tools, beginning with the cause and effect diagram, also known as the fishbone diagram or an Ishikawa diagram, because it was Mr. Ishikawa who invented it. These are used to trace an effect back to its root cause. Then we have flowcharts. These display sequential steps to identify the meaning of complex processes in order to find the relationships and dependencies between events. Flowcharts are also referred to as process maps and show the relationships that exist between different processes. One specific tool to use as part of flowcharting is the PMBOK model, which we'll discuss in just a bit. Then we have the check sheets. These are also known as tally sheets, and they may be used for gathering and organizing data. Check sheets have been called the most basic tool for quality. Then we have the Pareto diagrams, vertical bar charts used to identify a set of priorities. And when we say priorities, we mean those few specific sources that are responsible for causing most of the problem's effect. So much for the first 4 of our 7 basic quality tools, which means we have 3 more to go, beginning with the histograms, which are a special form of bar chart that describes the frequency or central tendency of a variable in a set of data. With histograms, there is no consideration for the influence of time on the variation. Control charts, they are then used to show changes in a process over time. The control chart is the best tool for monitoring the performance of a process over time. And lastly, scatter diagrams. These are graphs that display the relationships between numerical data, one variable on each axis, to look for a relationship. If the variables are related, then the points will fall on a line or a curve. We mentioned the PMBOK model when we talked about flowcharts a couple of slides back. So let's take a look at the PMBOK model a bit further in detail here. First, you may be wondering, well, what exactly does PMBOK stand for? Well, PMBOK is obviously an acronym, and it stands for Supplier, Input, Process, Output, and Customer. It is a tool that summarizes the inputs and outputs of one or more processes and displays them in table form. But why on earth did we mention this as part of flowcharts? Because it's obviously a table. Well, flowcharts are often associated with the SIPOC model because flowcharts and the SIPOC model, they depict the activities, points, decisions, branching loops, and parallel paths just in different ways. A flowchart does it with boxes and arrows, and the SIPOC model does it in a horizontal table. This diagram here is an example of how flowcharts and the SIPOC model are useful in understanding and estimating the cost of quality in a process, as well as estimating the value for conformance and non-conformance work required to deliver the expected conforming output. And by the way, when it comes to the pronunciation of this, there's actually a little bit of a discussion going on around the world. Is it SIPOC or is it CPOC? Well, SIPOC, CPOC, please feel free to use either pronunciation or either pronunciation. We here on the Prepcast have decided to go with SIPOC. We talked a lot about the cost of quality earlier in this lesson. The cost versus the benefit is only one aspect. What about the actual results of these quality management practices? Which ones actually work? For example, is classroom training an effective way to improve the quality of our product, or should we adopt a buddy system instead, where an experienced craftsman is teamed up with a less experienced one? Or in another instance, when we need to manufacture goods, there are usually multiple manufacturing technologies available, and the question is, how are we going to figure out which of the technologies is going to deliver the quality that we need? The answer to these questions can be found by implementing the technique of benchmarking. Benchmarking involves comparing actual or planned project practices to those of other projects to generate ideas for improvements and to provide a basis by which to measure performance. Benchmarking is all about comparing the quality standards of one project to the quality standards of another. The purpose of benchmarking is to evaluate the differences between the two projects and then to make corrective actions to the current project. Let's continue along this line of thought for a minute with an example. We use benchmarking to figure out which processes are best suited to create the desired quality in the end result. But what about the end result itself? Let us assume that our company is in the gardening business, and our intention is now to move into the garden shed market, but not into every single cheapo shed that you can buy anywhere. Oh no, we're talking about the very lucrative high-end shed market, to be exact. Many people like their shed in the garden to be more than just a place where you put tools. It's more of an extended living room with all of the creature comforts that you could think of. So the decision has been made that we want the shed to be made out of wood. But the problem areas that we are experiencing are which woods will deliver the type of homey feeling that we want to convey to our customers. And what about the windows? Are they going to be wood-framed, plastic, metal, single-pane glass, dual-pane glass? There's only one way to figure this one out. Experiment. Design of experiments, also abbreviated as DOE, is a statistical approach that uses data analysis to determine optimal conditions. It relies on what-if scenarios to determine what variables within a project will result in the best outcome. This approach is most often used in the product of the project rather than the project itself. For instance, instead of conducting a series of individual trials, an information technology project may use design of experiment analysis and optimize hardware and bandwidth needed to run an internet-based application, finding the optimal match of system response time. In the plan quality management process, we want to use this technique to find the most effective quality tests to use on the project and the most efficient number of quality tests to use on the project. Our next tool and technique is statistical sampling. This refers to the study of populations by choosing a part or sample of the population of interest, gathering information about it, and analyzing it. Sample frequency and size should be determined during the plan quality management process. We do this so that the cost of quality will be determined by the number of tests and expected scrap and so on that is produced by our quality approaches. Statistical sampling is a considerable body of knowledge, and it is the base for a large quantity of information. There are countless other quality planning tools that are used to define the quality requirements and to effectively plan quality management activities. Some of these are designed by specific industries and with a specific use in mind. This list is in no way inclusive of all those tools, but those mentioned in the PMBOK guide are brainstorming. This is, of course, a creativity and information gathering technique used to generate ideas. Then we have the force field analysis. This decision-making tool uses diagrams of the forces for and against a change and helps you to communicate the reasoning behind your decisions by analyzing these forces. There is the nominal group technique. This technique is actually a type of brainstorming. With this, ideas are brainstormed in small groups and then those ideas are reviewed by a larger group. Nominal group technique encourages input and contributions from everyone in the group and prevents those who are more vocal from dominating the discussion. And the last one we'd like to talk about here, quality management and control tools. Also a tool and technique for the perform quality management process. It is used to link and sequence identified activities. It's important to note that these quality planning tools may not show up on the exam. However, you will need to know that the term additional quality planning tools is one of the basic tools and techniques used in the plan quality management process. And so we have reached our final tool and technique for the plan quality management process, and that tool is meetings. We all have to suffer them occasionally. The project management team may hold meetings to develop the quality management plan. The meeting attendees could include the project manager, project sponsor, the project management team, members of the team, or anyone with project quality management task responsibilities. And with all the tools and techniques reviewed, we are moving on to the outputs. There are 5 outputs that are specifically mentioned in the PMBOK guide. They are the quality management plan, the process improvement plan, quality metrics, quality checklists, and project document updates. And we're going to do a detailed review for each of these 5. The primary output of the plan quality management process is, of course, the quality management plan. It's a component of the overall project management plan. It describes how the organization's quality policies will be implemented on our project. In some sense, it can be viewed as a roadmap on how the project management team will meet the established quality requirements for the project through design reviews, documentation, and other protocols. The quality management plan also gives management as well as the customer a clear understanding of how quality will be maintained and what quality documentation they can expect during the life of the project. The quality management plan may be formal or informal, detailed or general. It is all dependent upon the requirements of your particular project. A review of the quality management plan should occur early on in the project to be sure that decisions that are being made are based on information that is accurate. One of the things that could result from not doing this would be schedule overruns created by rework. At this point of our review, let's take a step back, all the way back to our inputs, to the organizational process assets, which are an input to the plan quality management process here. These assets include organizational quality policies, procedures, and guidelines that are endorsed by senior management for our organization. as a whole. They also define the performing organization's attitude about quality across all projects. If you look at this logically, you will agree that since the quality policy contains the instructions and directions of the organization's senior management, our senior management, our superiors in the end, then our project must incorporate this policy. The best place to document how we will implement this policy is in our quality management plan, which is the first and primary output from this process. Remember, we have already stated that quality is planned, designed, and then built in. So having an encompassing quality management plan is the first step. In it, we define the processes and approaches that will later be used in perform quality assurance and control quality. Another output from the plan quality management process is the process improvement plan. The concept of process improvement is tightly linked to quality. The process improvement plan helps you to identify waste and non-value added activities. It details the order for determining project management and product development to realize the activities that enhance their worth. The process improvement plan, another component of the project management plan, details the steps for how quality activities will be streamlined and improved over time. In improving processes, you are able to improve upon quality activities and evaluate their financial effect as well as their benefits. This typically leads to increased customer value and satisfaction. For the exam, you should also know that the process improvement plan should contain the following 4 segments. First, the process boundaries. These describe the purpose, start and end of processes, their inputs and outputs, data required, if any, and the owner and stakeholders of processes. A sound description of the process boundaries, what's in it and what's not, does wonders when communicating with stakeholders. The process improvement plan will also contain the process configuration. This can be in the form of a process flowchart with interfaces that will make analysis easier. Because we're talking about quality here, you will need process metrics. These will help you to maintain control and understand the status of your processes. And finally, since the goal is to improve our processes, we must also include targets for improved performance in the process improvement plan. This will guide your process improvement activities. What cannot be measured cannot be improved. This statement forms the basis of why we have quality metrics defined and measured. Establishing quality metrics is very important to ensuring the stability and performance of the project because they are directly related to performance, and they are here to achieve greater transparency and compliance with the project requirements. So, what is quality metrics, or what are quality metrics? Well, a quality metric particularly describes a project or product feature and how the control quality processes will measure it. The result, a measurement, is an actual value with a tolerance that defines the acceptable variations to the metric. Quality metrics are defined in the planning phase of the project and then measured throughout the project's life to track and assess the project's level of conformity to its established quality baseline. Quality metrics are extremely helpful in bringing into focus defects as they occur and inspire the need to comply with project requirements, thus preventing avoidable rework at a later stage in the project. Yet another output from the plan quality management process are the quality checklists. A checklist is a structured tool created to ensure that all steps were performed and that they were performed in the proper sequence. A checklist should contain the acceptance criteria that is included in the scope baseline. Checklists may be simple or they may be complex. This is based on the project's requirements. Checklists are created here in plan quality management, but they are used in the control quality process. Many organizations have created standardized checklists to ensure a level of consistency across the organization. However, do not make the mistake of simply adapting these standardized checklists without looking at them on your project. Make sure you adapt them to your needs. Our final output are project document updates. As quality planning is performed, it's normal to find things that need to change, and therefore you have to update documents with these changes. 3 examples here. The stakeholder register may need to be updated. This is covered in the lesson on project stakeholder management. We need to update this because we may have learned more about the quality needs of certain stakeholders, and we want to document that in the register. Then we have the responsibility assignment matrix that we may need to update. This is covered in project human resources management, and here we may need to assign quality activities to specific resources, and the best place to do that is of course in the RAM. And lastly, we may need to update the WBS, the work breakdown structure, and the WBS dictionary, because we want to input additional quality information that we have learned about as we planned our quality on various work packages that are documented in the WBS. Let's review. Plan quality management is named appropriately because it is the process where the project team identifies what the quality specifications are for the project and how those specifications will be met. We want to plan quality into our project, not inspect it in. Quality should be planned, designed, and built in from the beginning of the project. The focus should be on prevention. By doing it right the first time, quality work is produced and it eliminates the need for rework, which creates additional cost. Achieving quality can be expensive, so as a golden rule, all benefits must outweigh the costs. Your primary output for this process are the quality management plan. This is the key output. It describes how the quality policy will be met, as well as the process improvement plan. It details how to make the existing processes and activities better over time. So what types of questions do we see in sample tests online or in books? Well, generally speaking, quality management is all about tools. So expect questions on the tools, like this maybe. What is the tool used to compare your project's performance against another project's performance? The answer is benchmarking. Or a project manager is working on a force field analysis. What is the project manager doing? The answer here is that the project manager is planning for quality on the project. Did you notice we didn't ask what are the inputs, tools, techniques, or outputs of this process and you just had to name the tool? Oh no. You have to understand the concept behind the tool. You have to understand what the tool is trying to do on your project and how it is trying to help you. Those are the kind of questions to expect. Those are the kind of questions you have to be able to answer. And with that, we have come to the end of part 2 and to the end of this lesson here on plan quality management. So Justine and I say goodbye. Justine?
Don't cry because it's over. Smile because it happened.
Until next time.